All right, let's go on to the next problem here. And I've got a little situation here. Let's see if we can sketch this out. When a rocket is launched, it climbs 50 feet for every 13 feet it travels horizontally. Draw a diagram to represent the situation, then estimate the rocket's launch angle. All right, so it climbs 50 feet. So if we're talking about climbing, we're going straight up and down. So let's just make a little arrow here. So the rocket is climbing 50 feet. For every 13 feet, it travels horizontally. So it's going sideways. This is not going to be perfectly to scale by any means. But let's just say, okay, so 13 feet is horizontal. So let's think about the rocket is launched at this angle right here. So launch angle. And so it's going up and to the right. And it's going horizontally 13 feet, but for every 13 feet it goes over, it's climbing 50 feet. So essentially you have a slope here, right? That should sound familiar. It's kind of like a rise over run situation. So let's think about what that angle would be given some of the relationships that we have talked about. So we know that if we're talking about our launch angle here, that we would label this side then as the opposite side, and this side would be the adjacent side. And of course we have the hypotenuse over here, but the number labels we have are on the opposite and adjacent sides. So if we then think about the opposite divided by the adjacent ratio, that would be the 50 feet divided by the 13 feet. So 50 divided by 13 would be, now I did this, work this out, is 3.846. Now that's a ratio, remember, that's not an angle, that's the ratio between the opposite side and the adjacent side for this situation. So now let's go back to our chart and say, okay, we're talking about the opposite and adjacent. So we're talking about this column right here. And we know that that ratio is 3.846 for our problem. So notice most of these problems, or most of these numbers are actually less than 1. But right in between here, we get that 3.846. So right between the 70 and 80 degrees. And if we compare those carefully, it looks like it's like almost halfway, not quite halfway between those two. So it's between 70 and 80 degrees, but probably a little bit less than 75 degrees, so it's less than halfway. So maybe about 74 degrees. I'd have to go to my calculator and look up to see exactly what it is, because we haven't dialed this in quite precisely yet. We're just estimating at this point. But what I'd encourage you to do is just look at your chart and say, okay, is that number less than halfway or more than halfway between the two ratios that you do know, and then make a little bit of an estimate. So launch angle, we're going to estimate about 74 degrees. All right, so we had talked about Pythagorean triples a couple units ago. And remember, a Pythagorean triple is a set of whole numbers that works for the Pythagorean theorem, that always makes a right triangle and therefore works for the Pythagorean theorem. So let's go ahead and just sketch out this triangle here. Sketch the triangle with side length 7, 24, and 25. So this won't be perfectly to scale here, but we know the longest side, the hypotenuse, has to be the 25. And so if we think about the names of those sides, and let's actually call that smallest angle A, across from the smallest side. So we have the hypotenuse, which I'll abbreviate as HYP. And we have the opposite side, which I'll abbreviate as OPP. And we have the adjacent side, which I'll abbreviate as ADJ. All right, so we look at the three ratios that we have been studying: adjacent divided by hypotenuse. So that would be the 24 divided by 25. And as a decimal, that is 0.96. And then opposite divided by hypotenuse is 7 divided by 25. And as a decimal, that's 0.28. And opposite divided by adjacent would be 7 divided by 24. And as a decimal, I think we'd have to round that. So we'll take it out another decimal place. That's about 0.292. So once again, let's estimate what the angles, actually it's asking for both angles. So let's start with angle A. And we could pick any of these ratios if we want to. So for instance, maybe this time we look at opposite divided by hypotenuse, which is 0.28. So let's go back up here. Opposite divided by hypotenuse would be this column right here, and we're saying it's 0.28. So 0.28 actually would be right in here, right? 0.28. If we think about how close that is to either side, it's actually a little bit closer to the 0.342, isn't it? So it's a little bit closer to 20 degrees than it is to 10 degrees. So again, you're going to have to do a little bit of estimation. So halfway would be 15 degrees, and so a little bit more than halfway, I don't know, let's say like 16 degrees. All right, and what about the other angle? If we called that angle B, what would that have to be? Well, once we know two angles, because remember, this is a right triangle, we know that's 90 degrees, then of course we know that that is the complement to that. So 16 degrees, 90 minus 16 would be 74 degrees. So we'll estimate. It's funny enough, that's similar to what we had here. All right. Are you ready for more? Find another Pythagorean triple and state it below. You might want to do an internet search for Pythagorean triples to find some. Estimate the acute angles in that triangle. Explain how you know. I'll let you guys decide if you want to investigate a little bit. It might be kind of fun to come up with some really, really big numbers for Pythagorean triples. You can Google it and see if you can use that same process to figure out what the angle would be in that particular situation. But for now, we're going to move on to the next page.